Okay, so this is going to be a video about your review. We're going to go over it as quick as possible. I know this way for first hour you'll be ready to go tomorrow. We're going to do this. Alright, so remember for our introduction, we talked about how scientific theory, scientific methods, things like that. So remember, no theory can ever be proven. You can't ever have a theory proven. It can only be stated as an explanation for something that has happened. So first step of the scientific method requires your senses to obtain information. So that is going to be gather info, or make observations. So gather info, make observations. Either one's fine. The variable that is observed during a experiment, that is going to be the one that is observed, not the one that you control. So that is going to be your dependent. So the one that you're trying to find the information on. Independent is the one you control. Dependent is what you are going to observe. What is matter? So we go into chapter 2. We talked about the changes in matter, the steps of matter, how matter are going to change, how matter is what it is. So remember, matter is anything that has mass and takes up space. So give an example of matter. Anything. So it could be anything from an element to a car to gas to even a photon. Okay. Give an example of something that is not matter. So a wave. So like a sound wave is not. So anything that is energy. Physical properties. Physical properties are something that can be observed. So like the weight. So like weight of an object or mass of an object. The density is a physical property. The color is so anything that is observed. Solids have a definite shape and a definite volume. Liquids have an indefinite shape and a definite volume. Because remember, if I have this jar of water, no matter if it's in the jar or if it's on the ground, it's always going to be 32 ounces of water. Gases are indefinite shape and indefinite volume, because they are going to change their volume based on the object that they are inside of. Physical change would be like melting or freezing. A chemical change is going to be different. Remember, that's like something changing into a totally new substance, so like burning wood. Heterogeneous mixture is going to be, you can see the difference. Think Chex Mix. Okay, and the first letter of the element symbol always has to be capitalized. I think I spelled capitalize wrong. No, that looks right. Alright, so now when we get to this chapter 3, we were talking about our scientific measurements. So this is where we talked about the metric system. Remember, the metric system biggest advantage is that it's in multiples of 10. So I can do it in scientific notation, like we talked. We just move the decimal over when we're trying to figure out different ones. Now remember, when we are trying to figure out Kelvin, it is going to be plus 273. So if I have a negative 34 and I'm trying to add it to 273, that's going to give me 239 Kelvin. And remember, it's not degrees Kelvin, it's just Kelvin. And now if I want to go from meters to centimeters, it's that multiples of 10, I can move it over. So that's going to equal 0.75 centimeters for every 0.0075 meters I have. Because remember, it is times 10 to the second, because there are 100 meters, or 100 centimeters in 1 meter. Don't worry about sig figs. We didn't talk about sig figs this year. Scientific notation, remember that's just multiples of 10 to where we move the decimal place to where there's only 1 in front, so it's 6.007 times 10 to the third. And since there's no unit, we don't have to put a unit. Remember, density is going to be mass over volume, so it would be 7 grams divided by 20 centimeters cubed. And remember, centimeters cubed is always equal to milliliters, so 1 centimeter cubed is always equal to 1 milliliter. Okay? Alright, moving on. Chapter 4, finally getting to the chemistry aspect of chemistry. So the smallest part of an atom that retains its property, the smallest form of an element is an atom. The smallest part of a compound is going to be a molecule. So remember, element equals atom, molecule equals compound. Okay. 2 subatomic particles found inside the atom in the nucleus is going to be your protons and your neutrons. Remember, protons are P plus and neutrons are in 0 because neutrons only have a mass. They don't have any charge. Protons have a mass and a charge. Your electrons do not have a charge, or not a charge. They have a charge, but they do not have a mass. Now, if I want an atomic number, is the number of both protons and electrons. Neutrons are a part of the mass, because remember, if we want the mass, so mass equals protons plus neutrons. So how many protons, neutrons, electrons are in an element with the atomic number of 50 and a mass of 125? I would look and I would get protons are going to equal 50, electrons are going to equal 50, and then I want to take 50 minus 125. That means I'm going to have 75 neutrons. Okay? Now, chapter 4 done. Moving on. Oh, you can figure out these. So which of the following isotopes represents the same element? So we would see, as long as it has the same atomic number, and remember, your atomic number is always going to be the bottom, because when we do isotope form, you put your mass on top, your number on bottom, so this one was not correct. So if we look at this one, we see it's 20, 21, 20, so none of these, so you couldn't do any of these, none of these are the same element. I look at this, 38, 38, 38, they're all good, and then I look at this one, I see none of the same atomic number. That's what I'm looking for if I'm looking for the same element. Okay? Chapter 5, electrons. I know we're going quick, but I know if I go over an hour, you all, like I should with this, you all will not pay attention. So I'm trying to give you the bare bones so that way you can study for your final tomorrow. Now, so what is the maximum number of electrons in the second energy level? Remember, that is 8. It is always 2, 8, 8, and then so on, and it changes once we get to your stupid transition metals because they're all the way, they are what they are. What is the electron configuration of calcium? So if we look, calcium is number 20, so that means we have to go all the way through. So we have 1s2, 2s2, 2p6, and because it is all the way through, we have to keep on going. 3s2, 3p6, and then it is 4s2 because that is what the group that it's in. So a stable, electron configuration contain how many suborbitals? Remember, it is always going to be it's always going to end in your p energy sublevels, because it has to have 6 p energy sublevels to have a stable one. Because remember, stability is always equal to noble gas. Emission of light occurs when an electron blank from a sublevel to a lower sublevel falls. Remember, the light happens when it falls. When it gets excited, it gains that energy, and then it loses that energy, expels that energy in the side of a photon. And that's what we get for that quantum of what we have. So what period number? So periodic trends, this is where we're talking about. We're going to the periodic table. I think we did these in reverse order, but that's fine. You get the gist of it. Periodic trends for phosphorus. Phosphorus is going to be in, so if we look at it, it is in the third period. So this is third period, so it gives this third energy level. Because remember, periods are this, spell it wrong, and then your columns are going to be groups. Okay, I don't call them families very often, but remember, groups, families, same thing, energy levels, and your periods are the same thing as well. So the majority of elements are classified as metals. 80% of the periodic table is metals. What subatomic particle determines the chemical properties? Remember, those are the electrons. They are the chemical ones. Your physical properties are your protons. How does a cation form? You're going to lose electrons, or lose valence electrons, which means it becomes positive. And if that means an anion is going to be negative, so it's going to be opposite. So it turns into negative, so that means it gains valence electrons. Okay, so what is the name given to the electrons in the highest energy level? Valence. Okay. Now, to the most recent, where we talk about ionic bonds and talk about your covalent bonds. So we called this Chapter 7 together. We just shortened it so that way we could get 2 quizzes in instead of 2 tests. So what is the charge of calcium? Calcium is in group 2, so that means it is going to be calcium 2 plus. It has a cation. It is easier for it to lose 2 then gain 6. Remember, we're always trying to count to 8. Try to get to that noble gas configuration. How does sulfur obey the octet rule? Sulfur is in group 16, so that means sulfur will be a 2 minus. So that means it gains 2 electrons. Okay. What is the net charge of a calcium and fluoride compound? Supposed to be 0. We have to get all compounds equal 0 charge. We always have to make sure that they are going to equal 0. So that means that calcium, which is a 2 plus, is going to go plus fluoride, which is a 1 minus. So that means we need 2 fluorides to equal our charge. So we have calcium F2. Okay. The ionic bond, an ion bond between 2 what ions? So between a cation, which is always going to be a metal, and an anion, which is always going to be a non-metal. Okay. So finally, on to the last one. We're only 14.5 minutes in. We could do this. I know you're going to listen to it on 1.5 times speed, so it's only about 10 minutes for you so far, so that's not too bad. Why do atoms share electrons? To obey the octet rule. Stabilize into noble gas configuration. Okay. Diatomic molecule C2 is formed with a single bond. Remember, all group 17 is single bonds. Remember, double bonds are going to be your group 16, triple bonds are going to be group 15, and then remember with group 14, they always have 4 bonds because there's only 4, so it has to share around. So that's where your carbon or your organic chemistry comes from. A pair of molecules, molecular orbitals. So how is a pair of molecular orbitals formed? By sharing valence electrons between two elements. Okay. Which covalent bond is most polar? Remember, that is hydrogen and fluorine, or fluoride, hydrogen fluoride. Because remember, they are the farthest away. So this is going to be the most positive of all of your covalent bonding pairs, and this one's going to be your most negative, because that's the electronegativity that we see on the trends on your periodic table. So they are going to create a very polar bond. So the weakest attraction between molecules is van der Waals. So weakest, hydrogen is next. Hydrogen bonds are next. Then your ionic bonds, then covalent. So that goes single, double, triple. Very strong, because that's where your network solids come from, with double, triple bonds. All right, so that is everything. That should cover everything. That it will help you with your study guide. Get it done. Get it going. Study. If you are on the borderline, I would take this very, very seriously. Okay? Thanks. Have a good Sunday or Monday if you're watching this on Monday. Just make sure you're studying. All right. Bye.